Welcome to the next episode of Learning with Lafferty. This is the blood video dealing with a different type of tissue. Okay, so within this video we're going to be talking about the blood system and the organ that it be. So like always, got to introduce Manee. Now random fact, Manee, you have all of the blood cells that I have except for one. Do you know which one it is? He does. Okay, so we're going to look at when we talk about the different type of cells that manatees have the same type of cells in the blood system that we have, except there's one slight difference that we're going to be looking at when we talk about white blood cells. Now, with like every chapter that I have talked about within my videos, always remember that a group of cells equals tissue, and then tissues equal the organ. So yes, your blood is an organ. Now let's kind of bring it back to the tissue level and talk about that. So when you remember thinking about the various type of tissues within our body, they were epithelial, connective, nervous, and muscle. This one is going to be a group of cells that floats in a matrix, the liquid, called connective tissue. So it is the circulating. Now I'll also have another video in a couple videos from now that will talk about the other circulating connective tissue, which will be the lymphatic system. Okay, but for today we're going to talk about the blood cells. 3 different types. Let's look at which one you're missing, Manee. And then we're going to look at the liquid that surrounds all of those cells that keeps us alive by giving us the oxygen that we breathe. Now, in a human, sorry Manee, but you're a lot bigger, so you're going to have more blood. Humans have anywhere from 4 to 6 liters, okay, far as the blood capacity. Okay, so think about volume far as the blood. Now, as far as the blood color, we know blood itself, and we're going to look at the part that holds that color of the hemoglobins. Scarlet red, a very bright red, tells me that that blood is high in oxygen. Now, in most textbooks, you're going to see red, and then you're going to see blue. Okay, now, technically within the body, a darker red is going to relate to the lower of the oxygens. Okay, but within the textbooks, you're going to see blue. Okay, so red is high in oxygen, blue is low in oxygen. Okay, but definitely know when you're kind of looking also at pictures and videos, sometimes if you see a very bright blue, very bright red versus a darker red. A bright red versus a darker red, that is high oxygen, low oxygen. That's definitely important to be thinking about, because the next video we're going to be looking at the heart that pumps around all this blood around our body. Now, a couple things you need to be thinking about always with any of the tissues in our body, these organs, okay, of the things that they do. Now, the generalness of the blood is transporting. Okay, now erythrocytes are the first type of cell we're going to be talking about here in a few minutes, and those are going to be the cells of the red blood cells that do the job directly of transporting oxygen and carbon dioxide around our body. So transportation is one of the functions of the blood system as a whole. Now, number 2 is regulation. Okay, now temperature. Temperature, you think about being hot and cold, will come from how much blood is within that particular area. Acid-based, fluid-based balance, okay, that regulation comes from our pH. Now, it's important to know that the pH of our blood is what our body is considered to be the normal level. So if you go back and look at that video when we talked about pH, think about within that video of 7's water, okay, and 7.35 to 7.45, a little bit below that, is going to be the normal amount that our blood should be. Now, if you kind of don't remember, I'll remind you now, but definitely go back and watch the video relating to the chemistry of 0 to 7, okay, is going to be acid, and then 7 to 14 is going to be more alkaline. So our blood is more alkaline due to that fact. Now, protection is the last thing. Okay, protection relates to the other 2 types of blood cells, our platelets and our white blood cells. Okay, Okay, now our platelets, better known as thrombocytes, they're going to protect us by blood clotting, okay, bleeding, okay, preventing us from bleeding out externally or obviously bleeding internally. Now, infection relates to our leukocytes, okay, and that's one of the ones you're missing, okay? So leukocytes are going to be our white blood cells, and they relate directly to preventing infection, okay? They're the fighters within our body. Now, you're going to see a demonstration here in a little bit that is, of course, going to talk about this stuff again because redundancy is not a bad thing. So you're going to see within that video 2 parts of our blood. We already talked about volume, 4 to 6 liters, but you think about within your body, we can have no more than that, okay? So definitely think about, and you'll see a jar, and you'll see the amounts of liquid. Think about, I can't go over that, okay? I gotta stay within that. So if I have more of something, then I have lesser of something else, okay, when you're thinking about the body. Now, the 2 major parts as far as the composition or the components that make up our blood are going to be the liquid, because every cell in our body has liquid around it, okay, so the liquid portion, and the cells. So the liquid portion we'll talk about first is going to be plasma, okay, so when you take whole blood and you separate it, take the cells away, and just leave the liquid, that is going to be plasma. Now, plasma itself, as far as the composition, you're going to see a couple different things. Now, no more than 90% of the liquid portion of our whole blood is water. So think about that, why the importance that we need to be drinking water on a regular basis. Now, the other items that are as far as the composition of your plasma are going to be these things that are going to help us as far as proteins and antibodies. Now, on the protein side, we have proteins that are going to activate our platelets. Okay, our platelets, we're going to see here in a little bit, are these going to be little tiny pieces that float in our plasma and are only activated because of the proteins that are within our plasma. Now, the other part of that is going to be these antibodies. Okay, sometimes the plasma, if you've ever given plasma, plasma can also be called liquid gold for a reason. Okay, because it has those antibodies within our blood that is vital to our immunity to help fight off infections. And so, of course, remember also within that you're going to find nutrients and hormones, okay, waste, all that other byproducts, okay, but most of the liquid that lives around our blood cells, that plasma, is going to be water. Now, the next part is the formed elements. Now, formed elements is a fancy name for AKA the cells, okay, so there's 3 types of cells, blood cells within this system. The first type is red blood cells. So let's talk about what red blood cells are, okay? Red blood cells are going to be erythrocytes, okay? So what is an erythrocyte? What does it do? Now, an erythrocyte itself, is the job of it is going to be carrying oxygen around our body. So something for you to definitely be thinking about is the numbers. Okay, so 2 areas on all of these cells is very important, is high and low as far as numbers. That's the first thing. The second thing that we're definitely going to be thinking about is the function. So the function of a red blood cell erythrocyte is going to be carrying oxygen and carbon dioxide, transporting, okay, around our body. The numbers that's related to erythrocytes is going to be 4 to 6 million. Okay, I've seen it kind of 5, most textbooks kind of put in the middle of 5 million individual little cells flowing around your body right now. So think of hyper and think of hypo. Okay, and I'll talk about the diseases later on in this video after the demonstration. Within the erythrocytes, there is little tiny pieces, and one of those little tiny pieces is called hemoglobin. Now, hemoglobin is the red pigment that carries the oxygen around our body. Okay, so view it like the backpack in some ways. It's picking up the oxygen, carbon dioxide, and carrying it around the body. Okay, that way the cells can get to it, use it, and then of course give back. Now, red blood cells themselves only live 3 to 4 months, okay, depending upon, obviously homeostasis would be 3 to 4 months. And after that time, they will die. Okay, now one thing unique about red blood cells is when they mature, they lose their nucleus. Now, every cell originally, when we think about back to the cell chapter, don't forget this, every single cell in our body, remember, initially came from stem cells. So they were the original, say, Adam and Eve of our body. Okay, so we're growing inside mom in the embryonic stage. We have these stem cells, have no purpose, and at some point a liquid enzyme is released, and it will tell this cell, now you need to be this for the rest of your life, you need to be this for the rest of your life, and so on. So the stem cell was the parent cell. So erythrocytes are coming from a certain stem cell that eventually converts, okay, and as it converts and matures and becomes a erythrocyte, it's going to lose its nucleus. Now, the nucleus is important if you remember back to mitosis, okay, cell reproduction. So if it's missing the nucleus, it cannot do that. And that's important to also understand when we're thinking about red blood cells. Okay, and I'll come back to that here in a minute. Now, with this hemoglobin, okay, this red pigment that gives us that dark scarlet color or a darker red, okay, depending upon obviously oxygen high and low, hemoglobin is going to be even broken down further of what it's going to do when those red blood cells die. So part of it, okay, hema and globin, the globulin side is a side that's going to relate to amino acids. Okay, so when a red blood cell, of course, is carrying these different ions and these different elements around our body, it's going to eventually turn that into amino acids. Remember, the amino acids are the little building blocks, the Legos per se, that if you put them together is going to make a protein. Okay, of course, going to help with the blood plasma to give it what it needs. Now, red blood cells on the other side, the heme side, is going to relate to iron and also relate to making bile. Now, the iron is important because we have to have iron in our body, enough of it to allow that hemoglobin to bind and attach to that oxygen or that carbon dioxide. So without enough iron, that connection is not going to happen. Now, also in that recycling part, besides the amino acids that we're going to have, you're going to see that a part of our bile, the pigments, okay, is going to be a thing called bilirubin. So bilirubin I'll get to in later videos, but bilirubin is going to relate back to our liver, and our liver is then going to use that pigment to make the bile, and bile's job is then going to break down the fats that we eat within our body. So your red blood cells are very important on the protein side and very important also on the fat side, the lipid side, okay, that we'll get to within later chapters themselves. Since erythrocytes cannot reproduce, it is important that they are made within our own body. Now, if you know anything back to the cells, and back to the bones, you'll remember that the bone marrow is where that all of your blood cells are going to be made. Okay, so the bone marrow is like the nursery that grows all of the blood cells that we need. Now, so far as erythrocytes, it's actually going to be your kidneys that release an enzyme, better known as a hormone, a liquid called erythropoietin, to tell the bones to increase the production of red blood cells when your oxygen levels go down. So think about like if you had a disease where you hemorrhaged, or you think of a disease such as anemia, you don't have a lot of red blood cells. Well, your kidneys are helping to filter your blood, and when they're filtering your blood, they're realizing, okay, the numbers aren't where they need to be. I'm not sensing enough molecules of oxygen. I need to secrete a certain hormone to tell the bones that we need to pick up production because the oxygen levels are way too low and the body is not at homeostasis. So definitely make sure you're understanding that when we talk about the kidneys eventually, okay, in future videos, that the kidneys play a huge role with the bones and where the red blood cells are going to be made. So red blood cells, as far as the marrow, is very important because that is where the other blood cells are also going to grow. Okay, so they cannot reproduce. They have to be made every single day. And it's crazy when you look at how many red blood cells are dying each minute. Okay, this time that we'd be talking about, you've been losing hundreds and thousands of them. Now, the second type of thing that's important when we think about erythrocytes, of them not obviously not being able to reproduce, is that function. Okay, that very huge balance that they have as far as homeostasis and the acid-base balance. Okay, so besides transporting oxygen around our body, they also play the role in balancing how much carbon that we're going to have within our body. So if you go back to the four main elements that we have, oxygen, carbon, hydrogen, and nitrogen, if I have more carbon, then I'll have lesser oxygen, okay? And that directly affects my hydrogen levels, okay? Remember, hydrogen is the H in pH, okay? So definitely be thinking about and understanding that also when we think about red blood cells. Now, the next type of cell are the white blood cells, the leukocytes. Okay, leuko means white, cyte means cell. Okay, just like with red blood cell, the erythro means red. Leukocytes. So leukocytes have 5, that's a lot, isn't it, Manny? 5 different types. Okay. So the second type of formed element, the leukocytes, we have 5 different names that you need to be familiar with. So they break them up into 3 and 2. Okay, there are 3 that all end in the word "phil." Okay, the phils. Okay, so neutrophil, eosinophil, and basophil. Now, all of these relate to general protection of immunity. Okay, they do the job of phagocytosis. Okay, so these neutrophils. Now, of those, the one that you do not have is the neutrophils. Okay, now neutrophils, process of phagocytosis in humans, is going to play the role of that general immunity. Okay, they're the ones, like if you get a cut, they're the ones that generally going to come to the site first and cause pus to happen. Okay, so they're going to be the little bodies you see within pus. If you've ever gotten an infection, you can thank your neutrophils for that. Okay, they're going to come up like little Pac-Man. Okay, like manatees going to the lettuce and eating. Okay, that's exactly what phagocytosis means. It means to ingest. Okay, so white blood cells are like a manatee eating all day. Now, neutrophils, eosinophils, and basophils, if you were to look underneath all 3 of these underneath a microscope, they call them granular sites for a reason, because the granular look that you can see underneath a microscope when you look at the cytoplasm. Okay, so it looks darker. Okay, it looks like it has little granulars within that, and that helps a lab technician, helps doctors to determine that, okay, if you've got more neutrophils versus eosinophils, okay, this tells me what type of infection can be going on in the body. This is the one, all of them, we'll talk about the agranulars here in a minute, all of them do phagocytosis in some form, helping with protect us. Okay, either be general immunity or very precise immunity. Now, them as a group numbers 5,000 to 10,000. That's it on a normal day. But think about higher and lower. Obviously, if you have an infection, we can go from 10,000 to multiply very quickly to 100,000. Okay, and then they would look at which one is increased to tell me kind of what's going on in the body. So neutrophils, eosinophils. Okay, eosinophils are the ones that help with allergic reactions. So if you have asthma, you can curse, okay, or thank eosinophils for keeping you alive. If you were to get a parasite, they would help to fight off parasites. And basophils, or baso, depends what part of the pond you're from, those are the ones that help with inflammatory responses when we have like histamine allergic reactions. So all of your phils, when you look underneath a microscope, they're going to have a granular, when you stain them, look in the cytoplasm themselves. So those are the grand phils. There's 3 of them. Now, The second type of leukocytes are going to be the mamma-jammas, as I call them. Okay, these are the fighters. Okay, lymphocytes and monocytes. Now, in future videos, you're going to see me talk a lot about lymphocytes, better known as T cells and B cells, and monocytes, which are also can turn into macrophages. So these are the fighters of our body. So anytime you get a shot, you get sick, T cells and B cells are going to be activated and multiply. They're also the ones that keep memory to keep us safe. Okay, they do very precise fighting and antibodies. Okay, T cells for Terminator, B cells for antibodies. Okay, they're going to keep us safe very precisely if something is trying to attack us because of the memory that they have. Now, monocytes and macrophages, these are going to be also a part of the big fighters when we're going against bigger foes, such as cancer. Okay, so I'll talk more in detail later, but generally the agranular, okay, so A means non, agranular, the two, okay, even though I know there's technically, monocytes, macrophages, B cells, and T cells, so you kind of can say there's a total really 4, but there's only 2 names that are associated with the agranular. So lymphocytes as a whole and monocytes as a whole. Okay, and these are the ones that you're going to see in our body that help with immunity, but they also can do the phagocytosis. So as a group, okay, all those different names I talked about of leukocytes as a group, only 5 to 10,000 individual cells. They only will increase when there's something attacking, okay? Unfortunately, it could be the body trying to attack itself. And again, that will come in immunity, autoimmune diseases into later videos. So the last of our formed elements, we've talked about erythrocytes, red blood cells. We've talked about our leukocytes. Now let's look at the last, okay, platelets, okay, platelets. Platelets are also called medically thrombocytes. So you think about when you have deep vein thrombosis. Now platelets are the ones, they have no nucleus, okay, they can't think for themselves, and technically they're not really a cell individually, they're pieces of a larger cell. Okay, now I kind of view it like an asteroid, and they break up into pieces. Again, they still come from stem cells. Okay, when you kind of look back at stem cells and that, again, being born within the bones. But these particular ones, these thrombocytes are going to help with blood clotting. Okay, they come from a giant cell called the megakaryoblast. And this breaks apart, okay, becomes these individual little platelets. And you're going to see again within the demonstration, it's going to show again kind of how they work. Now, platelets, I would like to view them as like the fire department. Okay, so think about if you have a fire at your house. Hopefully you never have or never will. But the fire department is just there, okay? The firemen, women are just hanging out. They're waiting for the alarm to go off, to go to the place where the problem is happening, okay? Now, platelets are waiting and flowing around your body. Number-wise, it's going to be anywhere from 150,000 to about 500,000. Okay, so again, a lot larger than our white blood cells, but still a pretty good amount. So they're just hanging out, waiting to go to where the problem is going to be. Now, platelets within our body are going to be within the blood vessels. They do not leave the blood vessels, but they go to where there is a damaged area. So just like the fire department, alarm goes off and then the fire men and women leave, platelets that are flowing through your blood, and again, lower numbers per se, are going to go to an area when collagen. So when you have damage to a blood vessel, that area is going to release some collagen. And collagen, view it like the fire alarm. Okay, so it's going to set off an alarm that tells the platelets now, okay, there's a problem in the body. There's an opening, okay, this blood vessel, we need to go to that spot and we need to fix that spot. So 3 things are going to happen, and one of them kind of happens actually before the fire alarm goes off. So the first thing that's going to happen when blood clotting is going to occur normally is when there's a hole torn, the blood vessel itself is going to do a little bit of a spasm and contract. Okay, so view it like a tourniquet. So if I have a hole here, it's going to slow down, okay, the blood that's getting to that particular area. So vascular spasm is going to be the name, or contraction. Now the fire alarm has went off and the platelet like, oh, there's an opening. We need to fill in that gap. Okay, so that's the second thing that's going to occur, is the platelets now are going to be activated due to plasma activating them. Okay, so there are certain proteins within there's factors that are enzymes within your plasma that are going to tell the platelets, now there's a problem. You all got the alarm go, you all need to get to that hole and you need to fill in that hole. So all the platelets start becoming sticky and they're going to fill in a plug to temporarily hold that area. Now, once that has happened and they're starting to stick and fill in that hole, as you're going to see in the demonstration, then all of these little fibers called fibrogen are going to go and stick also to the platelets. But remember, we got other things flowing by, especially red blood cells, that are going to fill in the gap to hopefully hold that area, bind it together, and do the process of coagulation. So that big fancy word of coagulation is literally blood clotting. So once that area clots, fills in that hole, then the tissue is eventually going to heal, and then of course you'll get a scab. But think about if you pick at a scab before it's completely healed, then you're going to get some bleeding, and then the process has to kind of start all over again. But just like on a fire alarm, once the fire department has put out the fire, watch for the hot spots, make sure everything is healed and fixed, okay, far as the fire is out at least, then they're going to leave and go back to the fire station and wait for the next alarm to go off. That's the same thing with your plasma. Okay, your plasma then is going to unactivate itself, meaning that it's going to tell the platelets, okay, it's okay, the alarm is gone, everybody go back, everything is safe at this point. So definitely, hopefully, viewing platelets like the fire department, that they normally, as far as homeostasis, will not go off, okay, and stick and prevent a problem and clog areas, but we do know there are conditions where we can have some abnormal blood clotting. Now, those abnormal blood clotting would be the names of thrombosis and embolus. Okay, so a thrombosis is when a clot stays formed, okay, and it blocks blood going to a vital organ, such as your brain, a stroke, or the heart would be a heart attack. Now, an embolus is when that thrombose, okay, is moved. Okay, so it's still a blood clot, it's still platelets that are stuck together, but an embolus is just when it dislodges, it kind of changes name. Okay, so a thrombus can be dangerous, but it's very dangerous once that thrombosis starts moving and becomes an embolus. Within this demonstration, I want to talk about the different components that make up the blood. Now, the liquid portion of your blood is blood plasma. Now, as you can see within this container, that 90%, actually a little bit more than 90% of your blood, if this would be your body holding your blood, of that liquid portion of your blood, over 90% of our blood plasma, the liquid portion of our blood, is a liquid that will hold the cells. More than 90% of it is made out of water. Now, the rest of it is made up of the following: antibodies, proteins, and various clotting factors also within those proteins. We're going to add those to our blood plasma. So as you can see within our blood plasma, I've added the following: the antibodies, the proteins, and various clotting factors. So we have proteins. Now the proteins, in some of those proteins, as you can see, those little white, those are going to be things that are going to help with our platelets that I'll talk about after a while. Now, the platelets are going to help with clots, but it's within the plasma that we have some proteins and it's these little strands of fibrin that is going to help when we end up with a cut externally or internally within our body. Now, other parts are the A for antibodies. Antibodies are going to, of course, protect us with immunity. Globulins or globulins, immunoglobulins or globulins, that is the part that's going to protect us during immunity So the next thing, as you can see here, are going to be the types of cells called formed elements that's going to live within our blood and floating around within our blood plasma. Erythrocytes, which are red blood cells. Leukocytes, which are white blood cells. And platelets are going to help with hemostasis, which is blood clotting. So all three of these things are going to go inside of our blood plasma. So as you can see now, we have our red blood cells, erythrocytes, our white blood cells, leukocytes, and our little green guys I made were our platelets. Now, all of those are within the liquid portion of our blood, called your blood plasma. Now, as far as numbers, erythrocytes are going to be the highest. We have anywhere from 4 to 6 million of these guys. The next on our list are going to be platelets. We have anywhere from 150,000 to 450,000. Again, these are just kind of averages. And then the last time of formed elements, the lowest amount is leukocytes, white blood cells. We have anywhere, unless we get sick, anywhere from 5 to 10,000. So definitely think about conditions that you would have more of those within your blood plasma. So obviously if you have lesser or more, so hyper or hypo of the red blood cells, think of conditions such as anemia. Hyper or hypo of the white blood cells, think of like conditions like leukemia, or if you have a immune deficiency. And then platelets, the little green guys, we definitely want to be thinking of those guys when it comes to more or less, again, hyper or hypo, we think about clotting problems. So those are the things that make up the components of our blood system. Now, erythro means red and cyte means cells. So red blood cells are used to carry oxygen around our body. Now, within this demonstration, I'm showing you the difference between a healthy red blood cell, such as this one that's intact, versus what's left of a red blood cell. So definitely think about conditions in our body where red blood cells no longer look the way that they need to. If they're damaged, they can no longer hold oxygen and carbon dioxide to carry around the body. Now, leukocytes, leuko means white, cyte means cell. So our leukocytes, we have 5 different types of leukocytes within our body. Now, the type of leukocytes are granular cytes, and you'll notice there's 3, and agranular cytes. Now, the white blood cells as a whole are going to help with a process called phagocytosis, which literally means to ingest. So the job of our leukocytes is to ingest things that are trying to destroy the body. Or, unfortunately, sometimes these white blood cells can turn on us and eat cells that turns into tissue, that turns into organs. So can a leukocyte, a white blood cell, turn on healthy cells? Yes. But for the most part, on a normal homeostasis day, they are not attacking the body, but they are doing phagocytosis to protect us from bacteria, viruses, and such. Now, the granular cytes, the difference between the two, A means non, okay, to kind of help you, is the phils. So we have a neutrophil, a eosinophil, and a basophil. So the 3 granular cytes, the phils, these are the ones that are our general immunity protection. They're going to help things like with allergies, if you were to get a parasite within your body, causing histamine release, okay, is the job of the granular cytes. Even though they still do phagocytosis, that's how that they are going to react after doing phagocytosis. Now, the agranular cytes, these are the big guys, okay. Now, I will have a future video that I'll talk about with the lymphatic system of how our lymphocytes and our monocytes, which are a type of agranular, okay, so agranular cells are still, okay, these leukocytes are still white blood cells. These will be the bigger guys. They have a bigger brain, and they're going to help when we get major infections or viruses within our body. Okay, we'll kind of see again in later videos how these guys are going to attack. But know them as a whole, that the function of a leukocyte is to do phagocytosis to help our body with protection and defense. Now, the last type to form elements are platelets. Now, as you can see, platelets are little pieces. They're technically not a cell individually. They are fragments of a cell that will come together in a process called hemostasis. Now, how do platelets work in the process called hemostasis? Now, as you can notice right here, I've got just a little tiny post-it note with a hole in it, and kind of relating this to our skin. And again, this is going to happen anywhere in the body. We can be externally or internally. Platelets are going to help to prevent blood loss, which is hemostasis, when the blood comes in contact with any tissue other than the smooth lining of the blood vessels. Now, when they discover and kind of sense collagen, then these guys, platelets, are going to slowly come together. Okay, they're going to stick together, and as they're flowing through the blood, are going to migrate to that opening. Before they even get to that opening to kind of clump together to form a plug, the body is going to hopefully do some vascular spasm, almost like a tourniquet, to slow down the blood flow in that region that has the opening or the hole, so that we're not losing a lot of red blood cells. So vascular spasm would happen first in the process of hemostasis. The second process would be those platelets coming together to make a plug, and the third would be coming from our blood plasma. So if we remember, within our blood plasma we had different elements, and one of those elements you can see floating around next to that plasma is going to be these little fibrins. These are little strands that are going to come up and help to fill in and make it more sticky at that area. Vascular spasm has happened. The next step would be the platelet plug. The platelets became sticky due to that proteins within our blood plasma. Next, these fibrins, strands, are going to help to strengthen that area. And then lastly, a process called coagulation, which literally is blood clotting, has occurred due to those elements combining. And just as quickly as this occurred, once there has been a scab that has formed and has completely healed this area, then all of those elements are going to go back to flowing within your blood plasma to continue around your body. Now, I'll talk a little bit, now that you've watched the video demonstration of the different types of blood cells, I want to talk about the disorders. So the disorders relate to, again, hyper and hypo. Hypo, deficiency of erythrocytes, red blood cells, would be anything that's below 4 to 6. Okay, 5, if you want to put 5 million in there. So think about anemias, okay? So anemias can come from different things. It can come from your hemorrhaging, obviously, if you cut off your arm, you're bleeding out, your blood level goes down. It could come from the red blood cells that are being destroyed, okay? You're going to see that within the next part of the video when we talk about agglutination and hemolysis, okay, when our red blood cells explode. It could be also that the red blood cells are dying too quickly, such as diseases of sickle cell. Living to 3 to 4 months, they die very quickly, and that's not a good thing. Or it could be coming from, there's some type of suppression, immunodeficiency that's happening within our body, radiation, things like that. But the big word is usually anemia. Okay, that's a deficiency, low number. Hyper would be a poly. Okay, so poly means multiple. That could be a sign of a cancer, especially within the bone marrow, that's causing an abnormal production of red blood cells too quickly. Even kidney disease, okay, because remember, kidneys tell the bones to grow more red blood cells. There's a disconnect in the communication that can also cause a problem. Now, leukocytes, white blood cells, you think of leukemias. Okay, so leukopenia, leukocytosis. Okay, so white blood cells, deficiency, the penia, would be like an immune deficiency. So it could be, HIV, it could be leukemia, or even vitamins. Okay, vitamin deficiency could also cause a problem. On the other side, okay, excessive cytosis, this is the one that, of course, lymphoma, again, bone cancer, especially the marrow, but when you have infection in your body is when you're going to see a spike, okay, a hyper. And then lastly, platelets, thrombocytes. You're going to see the cytopenia and the cytosis. Okay, so a low platelet count can come from a bone marrow disorder. You see a lot of that with liver disease. Okay, but of course, if you have radiation and toxins in your body, it could cause that number to go down. The hyper, okay, the cytosis, is going to come from cancer that's affecting that mega cell. Okay, so again, there's a cell that makes, remember, a giant cell, the mega kerocytes, that when it breaks apart makes the individual platelets. So obviously, if you're getting rid of the asteroid, there's no pieces to be broken up. So definitely know the differences between an anemia. Anemia affects red blood cells. Leukemia affects the white blood cells, and clotting disorders, also such as hemophilia, are disorders you will see affecting the platelets directly themselves. Now, there are counts called complete blood count that they can take your blood and get an HCT, and that is relating to that hematocrit, okay, and that is related to whether that your blood has the correct amount of plasma, correct amount of red blood cells, correct amount of white blood cells, and correct amount of the platelets. Think about that. Okay, so if they're measuring in, a tube and they're putting it in the centrifuge, they spin it around, there should be 55% of that in a normal tube. That would be your plasma. Okay, so 55% of your, the 100 number, a little bit more than half of it should be the plasma. And even within that, it needs to be 90% water, and then the rest of it would be those proteins and those antibodies. Now, if it's more or less, could mean obviously if you have lesser water within that, you could have dehydration. Okay, so it's a good way to see what's going on within the body. Now, if the plasma is correct, but then we get into the formed elements, think about hyper and hypo. Okay, so normally, okay, on that, 45%, the rest of your whole blood needs to be the formed elements. But you think about if you only have 30% of that, okay, that would be for red blood cells, that'd be anemia. Okay, if you have a poly more than that, okay, then you can think of those conditions. But then you can also think about the white blood cells, and the platelets, higher or lower, could affect and really shows what's going on within the body. So that's why getting labs done is very, very important. Okay, so knowing the basic, the average, but when you have annual checkups or blood work done, usually within that report it's going to have what normal should be, and then it's of course going to show what your body has and if it falls above or below that set range. Now, within this next part of the video, you're going to see a demonstration that relates to blood types. Now, there are 4 different types of bloods that you need to be aware of. There's A, B, AB, and O. Now, in each one of them, except for the O, we're going to have these little markers called antigens. Now, I'll explain it now, and again, explain it again within the demo. Antigens are markers on cells that a white blood cell is going to bump up against, and either it's going to recognize it and like it, or it's going to attack. Okay, that's important. So our blood types that we get come from red blood cells. Okay, that's very, very important. And you're going to see those little markers within the demonstration. So red blood cells floating through, like Manee floating through, and a white blood cell comes up and is like, oh, I don't recognize you, I'm going to attack you. Okay, or hey, how you doing today, mommy and baby? Oh, how you doing today, Manee? And everything's okay. Okay, so it's the white blood cells that we have to worry about when we do transfusions and with mommy and baby. Okay, that's important. So the other type of blood besides A, B, and O is the extra little marker, another little antigen called positive and negative blood, Rh factor. So the Rh factor is just another little marker that's on people that have positive blood. Okay, so if you have negative blood, you don't have an extra little marker, okay? It's only people that have positive blood that have an extra antigen. It's called the D antigen. So you really could say a D antigen is another blood type that kind of adds on to the A, B, and O. So very important, and I'll mention this within that demonstration of you got to know what's compatible. So you can always take your blood type. So if you're A, you can take A. If you're B, you can take B. If you're AB, you can actually take A and B and AB. And if you're O, you can take O. So everybody can take their blood type. Now everybody, including O, can take O. So think about that. If everybody can take their blood type and everybody can take O, only O can take O. Okay, so if you get the wrong blood type, and you're going to see within that demonstration, a certain thing is going to happen. Okay, the white blood cells are going to round up things they don't recognize, glue them, clump them together in a process called agglutination. And by doing that, the cells then are going to burst. Okay, and the name you're going to see is hemolysis. Hemo means blood, lysis means to burst. And that's definitely something you do not want going on within your body. So again, you getting a transfusion, that's where you would get the wrong blood type. Okay, now mommy and baby do what? Remember, they exchange blood. Okay, now remember, if you're negative blood as a mom, half of that blood type is coming from daddy, okay, from the father's side in your baby, okay, and unless you know the blood type of that person, if you're negative blood, there's a big, huge possibility that it could be positive blood. Okay, so if the baby is positive and you are negative as a mom, then antibodies are going to be made. White blood cells are like, I do not recognize you. Get out of here. Okay, it's going to destroy them, and that's bad. Okay, because it's missing, the negative blood is missing that antigen that would have caused antibodies to be formed within the body. So, of course, problems you can end up with that is, of course, oxygen levels would go down. The problem during pregnancy more that they worry about is because of, if you have one baby, then it could not only affect the baby with the positive blood. Mama now has antibodies because she was negative blood. It could attack the mom, okay? So meaning that the white blood cells within mommy, that also being exchanged to baby could not match, okay? Then you would have problems. Future babies, of course, then can also have a problem. So if you are negative blood, there's a big possibility during that pregnancy that you are going to get a gamma, RHO gamma shot, and that is going to help to basically, in the short of things, okay, we'll talk about it in detail in other videos, it's going to basically kind of tell the white blood cells of, oh, you recognize I'm giving you some information in this shot. This is, hey, it's okay, kind of calm down, it kind of suppresses the immune system somewhat to tell the white blood cells to not attack, not attack these red blood cells that are within the body. So conditions that you would think about with the wrong blood types is agglutination, which causes hemolysis, so that would be technically listed under hemorrhages in most textbooks. Now we're going to talk about blood types. Now we have several different blood types, as you can see within this picture. The first type of blood type is going to be type A blood, and I'll explain kind of coming off of our erythrocytes, our red blood cells with these little green and yellow and purple is going to relate here in a minute, okay? So type A blood, type B blood, type AB blood, and type O blood. Now, I'll also will talk about here in a second the difference between positive blood, which is Rh factor, and negative blood. Okay, and again, red blood cells, erythrocytes, are going to hold the key to our blood types, and that is very important. Now, type A blood has a little marker on it called an antigen. Now, definitely want to understand the difference between an antigen and an antibody. Okay, an antigen is something that the body views as foreign. Okay, now, is that, could my blood be foreign? Yes, if you're receiving the wrong blood type. Now, A blood has this little antigen in a certain shape, okay, or color, if that kind of helps you, and that's the reason I did different colors. So type A blood, if you notice, is the only one that has just that green. But you notice type A blood also has that same, because type AB blood is the universal recipient, meaning they can take everybody's blood. So type A blood can take type A, if you have type A blood, but you can also take O, because you notice there's no markers, okay, on type O blood. So type A can take A and O. B has a different type of antigen marker, okay, on that erythrocyte. And B can take B blood, and B can also take O. Now, AB blood can take everybody's blood, including O's, but the bad thing about O, it cannot take any of the rest of these. Okay, now here in a few minutes I'll show you why that is. Now, you could also add to that positive and negative blood. So RH is the type of factor. Positive blood has an extra antigen. Okay, it's called a D antigen. So just like A has an A antigen, B has a B antigen, AB has an A and a B antigen, O has none, okay? RH positive blood has an extra marker, a D antigen. So technically you could actually on these, okay, so if you had A positive blood, go ahead and put another marker on that erythrocyte. Okay, so you can kind of hopefully visualize how that would be if you have positive. Now, if you have negative blood, I'll take it away because there is no extra antigen on negative blood itself. So definitely know the types of blood, who can take what and who can receive. Now, as far as universals, AB blood is the universal receiving blood because you can take all the blood types as far as A, B, AB, and O. And O is the donor because everybody can take that. We'll talk about the positive and negative aspect a little bit more with pregnancy or with transfusions here in a second. Now, you have to remember within our blood, we have those leukocytes. And remember, the job of a white blood cell is to attack things that it views as foreign within the body. And that's done, a lot of it is done through those markers, okay? Remember those antigens that I talked about? So when the body sees that there's something that should not be there by bumping into, so those white blood cells would bump into one of these red blood cells. If it does not recognize that marker, that it should not be in the body, that antigen, then it's going to release our antibodies. Now that process is called agglutination and hemolysis. Now, agglutination is a clumping together. So a white blood cell is going to then round up and clump together all of these red blood cells if it does not recognize the antigens that are on the outside. Give type B blood and receive type A blood, then the white blood cells are going to round up and agglutinate, kind of means gluing together the red blood cells. Now, by doing that, that's going to cause the process of hemolysis. Okay, hemo means blood, lysis means to burst. So what literally is going to happen, and I'll put one here so you can kind of see that? That's not good, okay, because all of that red that got squirted out, that was carrying the oxygen within our body. So no, agglutination and hemolysis occurs when you receive the wrong blood type. Now, going back to RH plus and minus. Now, someone that has positive blood, remember, has that extra marker on their red blood cell. Now, if you do not have positive blood, you have negative blood. Negative blood does not have a marker, so it's very similar to O blood. Okay, O blood does not have any of those markers that are white blood cells could cause agglutination to occur. Remember that clumping and that hemolysis to occur. So it is very important, more so for babies, because if mama is going to be a negative blood and the baby, because half of your blood type comes from daddy, is positive, then that's going to cause the white blood cells to not recognize that marker. And then guess what's going to happen? Agglutination is going to happen. It's going to start clumping those red blood cells together. And then the worst thing that will happen next would be hemolysis. It's going to cause all those red blood cells to start being destroyed because they're foreign within the body. So remember, it is the leukocytes and antibodies. Again, I'm not going to get too deep in this videos, but antibodies can be coming directly from the white blood cell, or they also could be released before and be floating in your blood. Okay, so know that they could be like attached to the white blood cell, or they could be free floating within your blood plasma. And that is what is going to attack the red blood cells according to what type of blood type that you have. It's looking for these little markers that are going to be on your erythrocytes. And remember, positive and negative blood also either have or do not have that marker. So if a mom has positive blood, no problem, okay, because you can have a negative baby and that's okay. It's only when you have negative blood and positive blood is introduced to that, the white blood cells do not recognize that antigen and then will cause agglutination and hemolysis to occur. So hopefully within this video you've learned a lot about the blood. The first thing hopefully you have learned about the blood is to appreciate your red blood cells that bring the oxygen around your body. The second thing you should have learned was knowing about those white blood cells that are protecting you every single day, fighting infections. And then number 3 would have been the platelets that help you from bleeding out. Also, the random fact of manatees do not have neutrophils, that white blood cell within their body to help protect them. They have a different type, kind of similar in some ways. So I look forward to seeing you within the next video.